Research complete.
Hello friends, my name is Kumar. Let's start a new topic related to PID and Labview. Okay, it's very amazing project because it's using industrial as well as major project you can use it. Okay, and in this project we learn lots of things step by step. Okay, first time explain about a little info about the PID. After it come on the block diagram, I will explain you step by step what's the purpose and which type of equipments we need. Okay, then come on the programming. Okay, in this project we don't need any hardware. Okay, we simulate on the Labview. After it's come on the project, or we can say hardware like Arduino, or we use servo motor for indicate and you easy to understand. Okay, in this video I'm telling about what is PID. Okay, PID used in the industrial where is have a lots of tank work. Okay, like have a pressure transducer, temperature transducer, or a liquid transducer. Okay. What's the purpose of PID? Because in there how we need to maintain the level of temperature or pressure as per the requirement. We need to set a point. If we need to set a point, like I'm set in a 60, okay, like I'm set on the value 60 and start to auto, and it's automatic after a few seconds, it's, or we can say after a few minutes, it depends upon your parameters. After a few seconds it's try to maintain the level, like you are enter a 30 set point, then it's try to maintain like 28 to 32. It's vary in this between. Okay, no need to any requirement to increase the temperature or a ventilation for maintain the level. Okay, help of PID we can easy to control. We can easy to control help of set point. Okay, now let's you take example. If I set a point is 20, then if your water level, or we can say liquid level, is 80%, and that time your valve, we can say control valve, that's analog, or we can say as like a solenoid valve, but it's vary between 0 to 100%. Okay, valve open, and you set a point is 20, your tank level is 80. That time your pump, or we can say control valve, is fully closed, not transfer one level to another level liquid. Okay, that time your we can say tank have a outlet water pipe. Help of this your water is going to decrease, or we can say inlet to the another process. Okay, that time your tank is try to decrease 80 to like we can say 70, 60, 65, 50, 40, and then 25. When your tank is reached 25, after that sense your control valve, and it's try to open the valve, because we need to maintain the level, because the set point is 20, and if your level is 25, that time is try to maintain the level, or that time your control valve is open 10 to 20%, and the flow level is 1 point to another level, it's transfer 10 to 20%, because it's try to maintain, because in the end have a outlet water pipe, the water is continuously outlet in another process. That's why the control valve is open as per requirement, because the set point is 20 and it's very like 25 to or 19, it's very in this between, it's try to control. That is the work of PID. Okay, if you try to work as like a manual, not need to PID, that's very complicated, because the industrial have a high pressure containers, and if have some manpower is forget to do control the wall or any another things, that is very dangerous for human lives. Okay, as well as you need lots of indicator, because help of this manpower is in know about what is going on here, then it's try to control. If someone is forget, that's very dangerous in life. That's why we are using the PID. Okay, let's start on the block diagram. I will explain step by step and you easy to understand, then come on the programming. Okay guys, let's go. Okay, this is our tank, and we take example of liquid. Okay, we can say liquid control, or we can say liquid transducer. Okay, any LT. Okay, this is liquid transducer. Okay, we can take example of LT, because in the industry have a different type of tanks, like we can use a PID, that is first is LT, that is liquid transducer, TT temperature transducer, and PT pressure transducer. Okay, different type of have. Okay, we take example of LT, level transducer. Okay, how we can control help of PID. Okay, this is our tank and this pipe is water in. Okay, and this is water out. Okay, now I am enter here water out. Okay, or we can say liquid out. Okay, as per your comment you can enter. Okay, now I am enter here inlet, say like water in. Okay, you can use liquid in. Okay, as per comment. Okay, and first of all have a one we can say wall, that is very important role in the PID. Okay, this is we can say a level control wall, LCV. We can type. L means liquid, C means control, V means walls. Okay, that is liquid control wall. Okay, and it's very important because it's as like a analog. Okay, this we can say now I'm enter here comment. This is as like a liquid vary. Okay, we can see variation 0 to 100. As per the comment you can change the value. Okay, means it's operate 4 to 20 milliampere. Okay, as like we convert into 0 to 100 means minimum is 0 and 20 maximum is 100, like this. Okay, we can choose this parameter. Okay, means it's variation. And LCV is, what is LCV? Okay, now I'll take example LCV. Now I take example, this is our LCV in industrial use, and have this is our pipe for water in and this is water out. Okay, I am enter here water in, this is water out. Okay, and in this between have some gap, that we can say it's a control. Okay, means have some we can say as like a solenoid wall. Okay, have a solenoid wall and it's as like this. When it's off condition or we can say 0, then it's blocked, or we can say water is not transfer this position to this position. Okay, when we change like we can say 0 to 100 like this. Okay, when we variation, when we set the value is 50, then this wall is open on half like this, then the water flow in this area, means water is flow 50% water flow in this area. Okay, not a fully, because we set a value is 50 in the LCV, because LCV is a variation 0 to 100. We can say open the wall. Okay, as like a potentiometer. Okay, that is the like analog value, means it's vary as per requirement, we can change it. Okay, not a constant, not a on and off. It's not as like a solenoid wall. Solenoid wall is work as like on and C and NO, only on and off, but it's a vary, means it's variation 0 to 100. You can easy to control as per requirement flow. Okay, if I set a value 100, then wall is fully open, then this water fully pressure flow one part to another part like this. Okay, this is our LCV, liquid control wall. Okay, now let's come again here. Okay, you know about LCV. Okay, this LCV connected in the water tank, or we can say have some water in other area. Okay, now I have, we can say water area plant. Okay, means plant, water area plant, water area plant. Instead we using LCV, liquid control valve, because help of this we can transfer liquid one position to another position. After that its process, our tank is fulfilled. Okay, now this topic is covered. Okay. Now let's come on the second, and we can say this is LT. Okay, this is LT, this is LCV. Okay, this is we can say liquid transducer. Okay, this is our tank, like we can 0 to 100 or 50. Okay, it's only a tank. Okay, now the main important that is this, or LT we can say process, we can say process control also, PC also you can say, or we can say PV also, process value, or you can say PV. Okay. Okay, and this is like we need to control a wall as per requirement. Now we can say set point. Okay, this is very important, because help of this we its PIDs operate. Okay, means you need to like your plant requirement have a like 60%. Okay, then it's a set point. It's depend upon your requirement. Okay, like its value 0 to 100. Okay, now let's take an example. First your LT, or we can say process control, is like 10% filled. Okay, 10% filled. Okay, okay, like this. Okay, okay, what you do first, when I attach, when I click to when I set a point here, like we can say have a 30%. Okay, this is 30%. I am set a value 30. Set point I set 30. Okay, after that have a switch that is auto and manual. Okay, it's depend upon you. Okay, we already know about we click to auto, not a manual. Okay, then I'm click to auto. When you click to auto, after that PID is processed and check it. It's open the wall first. It's check the condition. When I set on the 30, when I set the point 30, that time, or in the starting tank is 10% filled. Okay, but we need only 30, means I need to operate our tank process wall is 30%. Okay, and it's nearby 30. Okay, not increase more than 30% or less than 30%, have a plus minus 5 or 10. Okay, okay, when I set the 30 value, at that time after set, wall is try to open. Wall is first time it's fully open, means like this, it's a fully open, 100% open. Then water is flow, then water, or we can say liquid is flow here in this part, because it's open right now, because we set a 30 but it's now 10. That is open, and it's flow the liquid, and it's fill it. It's try to fill like 10, then 15, then 20, and then 25, then 30. Like we can say 30. When it's nearby 30, like 25 to 30, it's try to increase 25 to 30, because 30 set point is here. If it increase like we can say 25, then I'm taking example here 25, then after 25 we can say positive 5 or 10, always try to close. Automatic always try to close, means in the starting have fully open, and when the value is approx nearby 30, when our tank liquid is approx nearby 30, nearby set point, at that time your wall, we can say LCV, is try to close, means it's try to close. Like now is 100 open, then it's try to 50, then 40, then 30, means like 30, 40, it's approx open like 10 to 20% open. Okay, and now it's work, or we can say it's minimum or approx 30, like 28, 30, 32 nearby. When I set up point 30, that it's vary between 28 to 32, like this. Okay, or in the help of this, because it's pump is closed and it's open only 30 to 20%. Okay, after that 30 to 20%, and this process when the wall is open like a 30 to 20%, and after that it's maintain the temperature, or we can say liquid transducer, it's maintain as per requirement. Okay, when it change, like I'm taking example, when you touch to again like of 60%. Okay, when you set the point 60%, after set the point, that time it's fully open, because it sense, because you set a 60 point but is now it's 30%. That's why it's fully open, and the liquid pressure is move here and start to fill it. Okay, and it's try to increase like 40, then 50, then 55. After 55 it sense it and it's try to close it. Okay, means again I am take other example, because the set point is 60. After 55 to 60, it's try to close, because it's fully open, and when the value is nearby 55 or nearby set point, it's give the command to LCV, try to close the circuit. Okay, it's try to close the wall, and the water flow one point to another point, it's very less. Okay, means a very less, or 20 to 30% water flow to maintain the this system. okay, because the water out also flow on the on like we can say other plant area, have like a different tanks, and it's flow on this, and it's maintain the level of our liquid. Okay, like when it's set nearby 59 to 60, same here, like 58 to 62, okay, then its vol is very less, like 10 to 20%, because it's maintain the temperature, it's nearby this, it's very near between this, okay, because other water is flow here. And the last example is when you set the value is here, if you set the value is 20%, okay, if you set the set point set 20%, after 20% it sends LCV, and what it do, because your liquid is right now have a 60%, okay, now your liquid is 60%, okay, now your liquid is 60%, okay, when you set the point is 60 and your LT is 60, but after few seconds you set a value 20, okay, when you set a 20 value, that time your LCV is fully closed, means no water flow from this part to this, it's fully controlled, we can say fully turn off, okay, turn off, not able to flow liquid one place to another place, okay, because why, because you set a point is 20 and your previous value, your tank is filled 60, you need to decrease a temperature, or we can say liquid, okay, that time your LCV is fully closed, not able to flow the liquid, okay, because the inlet here, and it's try to decrease, okay, because the water is decrease here, okay, after few seconds when the water is decreased very slowly, like 60 to 50, 40, 30 to 30, 35, after 35, when again I take example, after 35 to 20, okay, like I'm entering 35 to 20, okay, in between this water, what is that, water LCV start to open very little, like 20 to 30%, because we need to maintain on 20, not a bill, not a very low, okay, because the water out here and it's 60 to try to come in 35, and after that we need to maintain the temperature nearby 20, that time your LCV is operate and it's open the wall nearby 10 to 20% wall is open, means 10 to 20% wall open, and the little your liquid is flow here, okay, little percent, like 10 to 20%, because we need to maintain, because it's need to maintain the temperature as per this requirement, okay, when I set the 20, then it's try to maintain that value nearby 35 to 20, sorry 25, sorry 25 to 20, okay, it's try to maintain, that time your LCVs operate only 10 to 20%, it's very, okay, like this, your water is flow and this is outlet, your water is go another plant, okay, and 20 to 30% water is filled here continuously, that's why it's try to maintain, that's the process of the PID in every field, like you are doing in industry have lots of project that's using a PID in PLC also, okay, in the Labview, that is very beneficial for your major project also. Okay, now let's come on the programming in the Labview. Okay, in the same process we try to understand help of the programming and simulate, and very interesting, because this is very important in your industrial life, or we can say major project, okay, because help of this our whole system is automatic maintain help of PID, it's very important part, okay, try to understand it, okay guys. uh, okay, let's come on the programming. Okay, let's start a programming. Okay, right click here, and first time create some we can say modification. Okay, now let's start a programming. Okay, this is our main. Okay guys, let's start a programming. Come on the block diagram, right click here, and click to control simulation, pin this, okay, and have a PID, click it, PID advance, and drag here, okay, and in this PID have everything like set point, okay, control wall, about which range also. Okay, everything in this PID. If you know about the backup of programming, double click it and you see control T and you see how a background programming is this. Okay, this is a PID background programming. Okay, have everything like you see set point, highs is 100 and minimum is 0. Okay, everything here like output range is 100 to minus 100. Okay, you can change to 0 also. Okay, this is depend upon you. Okay, now let's start. I'm close this circuit. Okay, now click to question mark and drag your mouse and you see have everything here. Like this is manual control, this is your liquid control wall. Okay, and this is auto and manual as per comment output range. Okay, okay, let's start step by step. Okay, this is manual control. Right click here and create a control. Okay, this is your manual control. Okay, drag here. Now I'm changed the title liquid control wall because we are work on LCV means liquid. Okay, this is a PID of liquid wall. Okay, liquid transducer we can say, uh, liquid transducer. Okay, LT, this is PID of LT. Okay, okay, now next is auto and manual. Create a control. This is auto and manual. Okay, okay, now next is output range. Right click here and create a constant. Okay, this is your output range of what LCV, liquid control wall. This is your output range. Now I'm enter here 0 to 100. Okay, now well, and this is your set point. It's very important. Right click here and come on the silver numeric. I'm choose this one. Okay, this is your set point. Okay, now this is your set point and set point value is 100. Okay, 0 to 100. Okay, now what you do, right click here and click as view as icon, drag here and connect to this one set point. Okay, now the next one is processor variable. It's depend upon your output. Okay, we now we connect output and data terminal. Okay, this one is PV process variable. It's we are connecting to the output of our plant. Okay, now ignore this. The next one is set point range. Okay, not need to enter a set point range because we already enter here. This is a maximum, this is minimum. Okay, not need to use this set point range. Okay, the next is PID gain. It's very important. Right click here and create a control. Okay, drag here, click as view as icon. Okay, now this is your PID gain. It's very important. Now I'm drag here because this is your proportional gain, and when you change this and your wave in a graph, you can easy to know what's going on. Okay, you can do R&D also. Okay, it's depend upon you. Okay, now let's we don't need to change right now. Okay, same here. Okay, the next one is GT. GT is the time second of your program running condition. Okay, if you give minimum value, okay, then your process is very fast moving, not able to see any graph. Okay, that's why we need DT also. Right click here, come to timing, create a wait until next multiply. Okay, create this one and I am enter here value, create constant that is 100. Okay, and we need to multiply to some value. Now I need create a multiplication, then I'm connect to this terminal. Okay, and I am enter here create constant that is 0.001. Okay, I'm and next connect to DT. Okay, this is our delay time. Okay, Okay, this is complete and this is our output. Okay, now let's create a output of plant. Right click here, come to select our vi. Okay, follow step by step. Click to C. Okay, then open prom file 86, then search ni nice instrumentation. Then you need to open your Labview version. I'm using Labview 2020. It's depend upon you. If you're using 18 17, then open it. Then have our examples. uh, Now open control, click to PID, click to sub VI, and you need to select plant system. Okay, this is our output of PID. Okay, okay, done. Now what do you do? Have a output and you see have a plant input and plant output. Now PID output connect to plant input because PID is control to the plant. Okay, that's why connect here. Okay, that is GT. GT is connect to same to this terminal like this. Okay, all done. And this is process parameter. It's very important. Then what you do, right click here and create a control right now. Okay, let's we change when our program is running condition. Okay, now I'm not do anything. Okay, now I'm drag here. Yes. Okay, this is process parameters means our output. Okay, now you see have a plant output here. Okay, now what we do, uh, first we create a one tank, right click here and come to silver numeric and create this tank. Okay, this is our tank process. Okay, now we need to modification as like our industrial. Okay, okay, this is our tank or okay, this is our tank or we can say process value PV. Okay, process value means output. Okay, this is your process value. Okay, now we need to connect here this terminal to this one. Okay. Okay, now we need create a graph for indication. Okay, now what we do, now I'm create a graph. Right click, sorry, right click here, come to silver, come to graph and create a waveform chart silver. Okay, otherwise you can choose waveform graph silver or waveform chart. Okay, let's I'm choose waveform chart. Otherwise, okay, let's choose another one. Come to silver, sorry, come to silver graphs. Now we are choosing waveform graph. Okay, okay, now create the size, increase it. Okay, now all done. Let's what we do, we need some modification. Okay, first what we do, first we need a graph and show value parameters. Then what we do, or right click here, come to array, sorry, come to cluster and we need a bundle. Okay, drag here. Okay, first we need to drag LCV. Okay, because this is liquid control valve, we need a value showing graph. That's why now I'm connected this terminal. Okay, then second one we need this output, or we can say here this is our plant output, we need to show in this graph. Okay, now what we do, I am enter here and click to this terminal. First I increase one terminal also. Okay, and this is our process variable. Okay, now what we do, this is our process variable, and sorry, we need to change this mm, name, and this is set point sp. Okay, now second one, we need to click this terminal sv. Okay, now I'm drag here on the front side. Okay, now I'm second terminal, I'm connect here to this terminal. Okay, the last one is our output. Okay, now what do we do? uh, because we needed some feedback in the PID. Main important part is feedback in your plant. Like have a lots of plant, have lots of tank in the process tank, like liquid control process, temperature control, they have a feedback process. Means some heating process, and same have a ventilation also, because it maintain the temperature, and we can say loop each other and give the data one each other to maintain the system. That's why feedback is very very important. If your plant have feedback, then we are using PID. Okay, because PID is depend on the feedback only. Okay, now what we do, it's our process variable. It's very important because help of this, because this is a process variable, or we can say control. This give to signals to this plant. Okay, now what you do, now process variable, click this terminal, open this, and now I'm connect to this terminal. Okay, and you see one feedback is created here. Okay, now I'm drag here, because this feedback, output feedback, is give to this one. After that, it's analyze what's a variable, or we can say what's the value in the output. Okay, that's why feedback is very very important. Now not need to this location. Now I'm delete this, control B, sorry. Okay, control B. Now if you need to this node, how you can find it? Now I'm delete, right click here, come to structure, and you see how feedback node, drag here. Okay, now what do we do? Now I'm click here and connect to this our process variable, and the output is connect to this terminal of our plant output, and this terminal connect to this one. Okay, now you see uh, the this output is go to our plant input. Okay, after that it's give output. Okay, and that output give a feedback to this one. Means if have a some value of output, like if have a like 4, or we can say if I enter here 100, if our value is 50, then it's due to feedback to this PID. Means your output is nearby 50. That's what after that it's going to work or control your wall as per requirement. Okay, that's why it's very important feedback. Okay, now what you do, okay, this is last one, we need to click and connect to this one. Okay, all done. Okay, now I'm increase the size. Yes, this first one is our LCV. Now I enter here LCV. Okay, the second one is our set point SP. Okay, the another one is process output, or we can say PV, process value. Okay, or we can say output also. It's our plant output. Okay, then I am entering output also. You can easy to understand. Okay, okay. Now set point, now I'm enter PV output. Our output is, I'm change the color, I'm taking a blue is our process output. Okay, and SP is a set point. Okay, set point I'm taking white is our set point, otherwise I'm choosing a black is our set point. Okay, and the LCV is I'm choosing because this is a wall. Okay, control wall, now I'm taking to the green one. Okay, it's easy to see. Okay, now all done. Okay, now what we do, open this, right click here, come to structure and create a while loop. Okay, right click, create a control. Okay, the next very important part is we need to give us some option. Okay, right click here and you see have a move initializer one loop out like this, means this loop is going on, then give us some value to this one. It's because we need to some value for starting. Okay, now what we do, right click here and create a constant. Okay, you see this is 0. You can control here but is not able to do here. That's why we need to do this. The initial value is 0. After that it's give the feedback to this one. Okay, now control T. Okay, now all process is done. Now we need to enter a parameter. Okay, this is important, otherwise you can run your program. After that you can change as per requirement. Okay, it's depend upon your R&D. Okay, you need to work on this. Okay, now let's start some modification as like a plant. Okay, come to tools. Otherwise what you do, right click here, come to silver, have a numeric, and you can choose this one also. Mm, okay, now I'm choose this one. Okay, gaze, sorry. Okay, gaze process, and I am enter here value that is 100. Okay, and size is like this. Okay, we need to increase the size. Okay, right click here and add needle. Sorry, no need to this one. Scale, style, and I am choose this one. Okay, scale, mark spacing. Okay, not need this. Scale, mark spacing, uniform as well, and scale, display format, style is this one as well. Okay, then mapping, properties, open this. uh, Data type, scale, minimum maximum, invert logging, show color ramp. Okay, display data, digit is 6, 5 digit 6, I am changing to. Okay, this is your value. Okay, no need this one. Select to 6, and otherwise you can select 3 because 100 is your output, or we can say maximum. Now click to OK. Okay, because this is your PID, sorry, this is your LCV. Okay, as like a LCV. Now what we do, come to tools and have some DAC module, image navigator. We need to modification. Okay, if you have you can do it, otherwise you can run, ignore this part. Okay, now I need to modification. Okay, I'm choosing some pipe. Okay, let's find it. Where is yes, you see have a pipe. Okay, now I'm choose this one, short horizontal or long horizontal, and drag here. Okay, now this is our input. Now click this part, sorry, click to this part, select this part and click to this and click to front. Okay, now this is your input, because have a some your in a plant have a some input here, in like a liquid tank or a lots of liquid supply. This is come from here. Okay, that's why I'm enter here. After that what we do, select control C, control V, control V, otherwise drag here and connect to this one. Same, select, click to back, sorry, need to do this. Select, click this, click to front. Okay, same here, click to front. Okay, this is your input and we need a output also. Now what do we do? Again select this, control like this, and I'm increase the size or change it. Okay, now it's different. Now open again, and we need to choose another one. That's okay, which one is best? Okay, now I'm choose this one. Okay, and change the size. Okay, this is your output, you can say. Okay, again open this and choose this one also. Okay, connect here. Okay, and delete this part, sorry, delete this part. Again open it, and choose some pipe like this. Okay, and connect to this one. Okay, it's depend upon your design. Okay, it's very important because first of all your design is very important. Okay, now all done. Yes, maybe done. Okay, okay, this is water in. I am enter here, not able to enter. Now I enter here water, or we can say liquid. Liquid in. Okay, I'm drag here liquid in and liquid out. Okay, this is your liquid out. Okay, now all done, and this is your not a gauge I'm using. This is LCV. Okay, this is your LCV, this is your PV, this is your set point. Okay, now let's we little modification, because help of this one we can easy to understand. Okay, it's very important. Okay, if you if you don't want to do this type of modification, that you can ignore this part and skip this video. Okay, but for me it's very important. Okay, we need a modification. Now I'm drag this part. Okay, drag here. Okay, we need enter parameter, like I'm enter here lt is liquid transducer. Okay, now I'm drag here the text, because this is our lt, like liquid transducer. Okay, again sorry, choose this one and this one. Okay, now I'm drag here, sorry. Okay, because this is our lt, and now what we do, again choose this one, control C and control V. Okay, we need little modification. Okay, okay, now what we do, again open this, and open this one. We needed some wire, or we can say some lines for understanding. Okay, now we choose this long vertical pipe. Okay, drag here and size band it. Okay, and now what we do, click here. Okay, and click to this part, do this and click to front. Okay, and again right click and create to front. Okay, all done. And this is your liquid probe. Okay, and help of this is a sense and give the signal to LCV. Okay, now what we do, right click here, sorry, click this and click to front. Okay, now you see it's LT. Okay, now again open that's one. Okay, we need to this one right now, drag it and size very less. Okay, this one. Okay, we need to connect to this terminal to this one. Okay, now what we do, um, size. Okay, now what we do, uh, copy this one, again copy this one, again copy this one, again copy. Okay, because we need a break point. Okay, break line. Okay, you can make like this, otherwise you can copy on Chrome and paste it. Okay, now what we do, select this and sorry, select this terminal. Now come here and connect to this one. Okay, okay, now again copy and paste it, again copy, again copy, otherwise I delete this part, again connect to this one. Okay, now you see this this LT is controlled to this liquid wall. Okay, LCV, because this give the feedback of this one. Okay, now what we do, again control C control V, sorry, control C control V, open this and connect to this terminal, and we need to size. Okay, click to this part and click this one, click to front. Okay, okay, now all done. Yes, now all done. And this is our LCV. Okay, now I'm choose this part, LCV, liquid control wall, and this is our liquid transducer. Okay, and style bolt. Okay, now you see as like an industrial same as like this. Okay, now all done. Okay, everything is done, and I already explained in a paper about this, and same as like this. This is our CP, this is set point. Okay, this is our LT, liquid transducer, have a one probe, those give the signal to the LCV. Okay, help of feedback, it sends the value and it's open and close the valve as per requirement, as per their maintain the level. Okay, now let's try to run it. Okay, now click to, okay, all done maybe. Yes, all done. Okay, now what we do, let's try to run this part. Okay, now you see have some problem of the graph. Okay, now close this, again press to control T. uh, okay, this LCV also not connected here. Now what we do, right click and change to, okay, change to, it's already an indicator. Now what we do, LCV, select here and connect to this terminal. Okay, because this is LCV. Okay, this indicate here. Okay, okay, now we need to connect a graph. Okay, graph is not connected here. Okay, now let's click and connect this part. Okay, have some problem, not able to connect this one. Okay, now what do we do? Okay, now we need to replace this graph to chart. Right click and replace it silver graph and click to this one. Okay, now click and connect this term. Okay, now all done. Okay, we need to change the setting. Let's enter 100. Right click here and not need export. Y-axis auto scale. Uncheck this terminal, and X scale, it's already unchecked. Okay, now all done. Okay, okay, and the another one is this style, not need this one. Okay, like I am choose this one. Okay, not need to do this. Okay, let's try to run it right now. Okay, all done. Okay, now click to run this, and you see our value, its display. Green is your LC, means this is your wall motor that's try to control or maintain the system. But right now you can say it's uh, okay, let's try. When I decrease the system, okay, you see blue one is your output of your tank. Okay, SP is your set point, that is indicate to the black wire, or we can say black color. Okay, and the LCV liquid control wall is display on the green, and now you see it's very like with zero value, and it's zero, it means it's closed, it's fully closed. Okay, okay, now what we do, when I increase the size, when I increase to 40, okay, and have some problem. Okay, now let's check it, what's going on here. Okay, first ignore this. You first we need to enter a parameter. Okay, enter 1.5. Okay, then we need to enter 18. That one is 1. That is 0. Same, this is 1. This is 0. This is also a 0, and this is 5. Okay, now all done, and we need to enter here 10. Okay, 0.05. Okay, all done. Let's what we do, we try to set a set point, and you see our LCV is not working. Okay, now we have maybe some problem. Control T. Okay, have some modification. First we do it. Okay, now you see have a saturation rate. Right click and create a control, sorry, create a constant. And I enter here value 0 to 100. Okay, all done. Okay, now let's do uh, again. Okay, you see have a manual control. Now click this and click to connect this. Okay, and the output is we need to connect to the output, because output is control wall. Okay, LCV. Okay, this is your LCV signal. Okay, now click this part and connect to this one. Okay, and connect indicator to this one. Okay, now all done. Control T. Okay, now what do we do? Okay, now let's to try to run, and you see it's working. Okay, well done. Now need some modification. Right click here, visible, and click to digital display. Same here, digital display. Same here. Okay, because you easy to understand. Let's try to run it. Okay, you see our temp like a set point is 10, and it's try to maintain the label 10, and you see right now your wall is fully closed. Okay, if your value is nearby set point, then it's try to open it. You see 4%, 5%, 6%, because it's try to maintain the liquid. Okay, now you easy to understand. Okay, when I'm increase the size, like I'm set to 90, and you see your wall is 100% open, your liquid is flow and fill this container. Okay, and in the outlet is you're continuously going on the outlet pipe. Okay, but if you are nearby this set point, and it's try to close the wall and try to maintain the liquid pressure in this container to this one. Okay, this process. Okay, that's why LT is control LCV. Okay, help of feedback. Okay, this give the feedback to this one LCV. Okay, this is our programming. Okay, graph is not connected here. Oh no. Okay, now connect to this one. Okay, now done. Let's try to run it. Okay, now you easy to understand. You see black is your set point is your 26, and you see it's continuously 26, and your blue is your process output. Okay, your output, and it's try to nearby your set point, and your like green is your wall, and it's try to maintain your temperature. You see, sorry, maintain your liquid. Okay, you see. Okay, and your process value is nearby set point. Okay, have a some point gap. Okay, otherwise the same. Okay, if you are try to increase 60, then you see your set point is try to 60, and your process value try to come to nearby set point, and your wall help a wall, and wall is try to control or maintain your liquid. You see. Okay, and if you are choose this one, or you can change this parameter, and you see what's going on in this graph. Okay, in the output. Okay, it's your R&D, you can do it. Okay, learn step by step. Okay guys, now our program is complete. In the next video we are using hardware also, help of servo motor. We try to. Okay guys, now our project is complete. Okay, in the next video we are using a hardware help of PID controller servo motor. Okay, that servo motor we are using to LCV instead of LCV. Okay, because do not have a LCV liquid control valve. It's very expensive industrial instrument. Okay, that's why I'm using a servo motor, and we control servo motor 0 to 100 or 90. Means 0 means its servo motor is 0 position, means closed. Okay, we need imagine. Okay, if have a 90 to 100, then our servo motor is moved to 90 degree. That means our wall is fully open. Okay, now in the next video we can use hardware also, and operate a servo motor help of control help of LT. Okay guys. Okay, thank you so much guys. If you like this video, please like and subscribe our channel. Thank you so much guys.